speaker. Today's speaker is an incredible speaker. I started following GeePaw on Twitter probably about a year ago. There's about 10 or 12 people that I follow on Twitter that are very experienced, very insightful, a lot of wisdom, a lot of knowledge. When I learn about people on Twitter, then I go to their blogs and their webpage, and I've done that with GeePaw. Highly recommend it if you are a Twitterer like me. Highly recommend GeePaw as a follow, and there's a lot of content on his website, so definitely highly recommend that as well. So I'm really, one of the greatest things about being the host of this webinar series is I get to invite people like GeePaw to come here and spread some wisdom. So I'm really excited to have him. And with that, let me pass this over to GeePaw. Thanks.
Cool. Thank you very much. I appreciate the kind words and introduction. Hi, folks. My name is GeePaw Hill. That's a kind of an unusual name. GeePaw is actually a nickname, and it means grandfather. And now you look at me and you're like, well, yeah, he probably is a grandpa because, you know, look at me, old, bitter, cynical. But in fact, it was an affectionate teasing name given to me many, many years ago. I was just 31 years old when I was presented with my first grandchild. And my friends and family thought that that was the funniest thing they had ever heard. And they took every opportunity to call me grandfather and grandpa and eventually GeePaw. And so now I've been GeePaw for a very long time, and I'm GeePaw out on the trade, not because of my senior wisdom, but because of how funny it was that I became a grandfather at such a young age. I'm sitting outside on my deck. I am not so very far away from you. I'm down in outside of Charlottesville, so about 2.5 hours from Dulles, something like that. And I give you fair warning, although the dogs are enclosed and everybody in the house has been instructed to be on tiptoes, can't guarantee perfect sound, so we may have to pause here or there, but we'll try to keep going and see how it goes. Today's, well, who am I anyway? Being a GeePaw is the best job I've ever had in my life. And the second best job I've ever had in my life, I'm a computer geek. I'm a coach. I'm a teacher. I'm a speaker. Mostly giving folks content and ideas about how to make software, well, how to make software. And today, what I want to do is actually talk to you folks about this concept right here. Now, my mission here is not necessarily to convince you or to prove anything that I'm about to say. Rather, I'm interested in perturbing you a little bit, shaking you up a little bit. One of the things that my work as a coach, and I've been a coach since the late 90s in software development, that has struck me over the years is the extent to which we have a strong tendency to buy into existing frames or framings of problems and solutions in a way that can be very misleading. You know, back in the, let's see if I'm good here. There we go. You know, back in the 80s and 90s, when I was first getting into this whole area of how to make software, you know, I read an enormous amount of old school design texts and process texts as well. And one of the things that you notice is that, well, actually 3 things that you notice about these old school books, and we'll get to that in a second. And these things are pretty significant in terms of their description of the projects that they undertake. First of all, they have very small scope. These projects are tiny. A typical example would be, and it's okay if you're old enough to remember this, a typical example would be a point of sale system for a video rental store. Remember video rental stores? Yeah, you're my people. So that would be a typical example of the kind of application that they would build. Secondly, their approach was entirely about single-threaded construction. It was, here's a project, and one person or one small team is going to make this beautiful design that will finish, that will complete that particular project. And I said finish there advisedly because that's the third feature. Inevitably, these projects described fixed and final targets. I call them a city on the hill, where we look out into the future and we say 2 months from now, this schmo in his video rental store is going to be able to sell and rent videos right at the counter using our system. And once that's done, the project is done and there won't be any further changes or enhancements or anything else associated with it. I make the joke that the project process for these folks was a very finely detailed 3-step solution to their problems. Step 0, nothing. Step 1, everything. Step 2, move on. And it's all intramurals. I, in fact, learned an enormous amount by studying those books and learning all about software design and software delivery from those sorts of examples. The challenge is, of course, that in real life, it's not quite like that. When you describe for me a problem, a software problem, instantaneously, almost before you have finished your first sentence, I will be breaking the problem into its parts. What can I tell you? Baby, it's a geek thing, right? This is what I do. I'm the sort of person, when you start describing a problem to me, I'm breaking it into its parts. And of course, back then that was fairly effective, and it worked like this. We would decompose the puzzle into its individual parts. We'd divvy them up among individuals or teams. We would put them all together at the end, and it would be done. And we would be done, and we would walk away. To give you a sense of, another sense of what that picture looks like, the sort of modern hybrid of that idea looks like this. We take a great deal of value that we've stored up through some means, nefarious or otherwise, and we get enough value that we're pretty sure we can make it to the after state. And then we determine our target. We carefully identify the final parts that are actually going to be involved in that. We split them up amongst multiple streams. The little chunks in here are meant to be the various sized steps, because all these folks are working in parallel, but they don't actually sync up very well or very often. So what we tend to do is have wildly varying step size. And then we have this integration or assembly process at the end. And then value received, sit back and wait for your stock options to mature. And this idea is really ridiculously common in the trade. You say to yourself, well, this is going to work. This is how we're going to do it. But I'm actually here to pitch a completely different idea. My idea says what you really want to do is focus your attention on creating stride limited activated steps. There's 3 criteria. So imagine yourself sitting there and you're saying, what should I do next? What steps should I take? There are 3 criteria. The step you're proposing must fit in the particular operational context that you're working in. So I say operational context. If I'm a coder, and I am, when I'm coding, I want my step to be on the order of well under an hour. In Kotlin nowadays, which is where I usually work, I would say well under half an hour. Most of my steps are 5 or 10 or 15 minutes long. So I'm talking about extremely limited strides, very small steps. On the other hand, if I'm a project manager or a product owner and I'm laying out stories, the stories operational context is something like 1 team day and a half, right? A day and a half of team time is how big I want the steps to be for my stories. And of course, if we're talking about changing process, we need still a little bit more time, 3-4 days, maybe a whole week. That's the biggest step I ever want to take. The second criteria is that it must be activated. I use the word activated. I'll be honest with you, off and on during this session, I'm going to actually change it back and forth between activated and shipped. You must ship the step. This step must be shippable in and of itself, independently of everything else that might be going on around us. So that's what I mean when I say activated. Now, of course, when we're talking process, that means it must be actually installed in the team. The team must be doing it. When we're talking about stories, we're talking about it actually must go. I know the reality is it's 70% of our work nowadays is websites and databases. It must be in the shipping production version. And then the third criterion, oh, and if you're coding, the criterion is it must be at head. That is, it must be pushed to the repo. So Stride Limited activated. The third criterion is non-negative user value. And what does that mean? And I'm saying it must not make my customer's life worse. Now notice, it's a very tiny change from our usual way of thinking, at least in terms of wording. But it's actually a gigantic change compared to that old school model, which says it must always make things better. It's in geek terms, it's the difference between switching between a greater than or a greater than and equal to, right? As long as it doesn't make anything worse, that step is legit. So we limit it by size, we guarantee it be activated, and we say, don't make things worse. Stride limited activated steps. Now this creates a picture. Oh, before I go there, what do I mean step? One more piece of this. There's the step. You throw a little cost at it, right? You are in a state of activation already. And this is reflecting one of the biggest differences between now and the 80s and 90s, which is that we don't work, ship. We work, ship. Constant state of change. So as a result, I'm defining step as the gap between 2 points of being activated. That gap is what I mean by a single step. And what I'm proposing is that we fix our maximum size in the particular operational context that we're in, and that we limit ourselves to only ever taking steps that are smaller than that maximum size. But there's your picture of that. And that creates a path that I'm here to shake you up if I can, to think that this is actually the most efficient path for your projects. Well, just look at it. Walking skeleton, we'll talk about that in a minute. But look how wandery it is. Why is it that wandery as opposed to that other beautiful path that we saw that had the 3 perfect straight lines towards rushing towards the finish line? It's because of those 3 criteria. If you set those 3 criteria up, you're going to be forced to take a path like this. Nevertheless, the contention I'm offering you is that this is the most efficient path. Now, let's take a look at this walking skeleton concept. What I mean here is I need a really bad version of this that barely works, but touches all the parts in the architecture. So if I've got 10 layers and each layer's got 3 significant, important parts, I'm expecting one story that touches every part and every layer and goes all the way from pixels to bits and from bits back out to pixels. That's what I mean by walking skeleton. And in order to make this work, you first have to throw all of your resources at the walking skeleton. But then as soon as you have that one piece in place, you can start using Stride limited activated steps to start changing that piece. Okay. So on the picture here, you're seeing that it might be a little hard to see on your screen, but these endpoints for these little purple arrows are different. All of them have red. That's because every step takes cost. All of them have, some of them have green. That's because, remember, we are permitting non-negative user value. The green is meant to represent user value. So in this little picture, the first 3 steps are all, or 4 steps are all producing user value, but the 4th step is not. Then the 5th does, the 6th doesn't, and so on. What about that little blue slice? What's the blue? The blue is the intrinsic benefit of taking steps. I'm going to talk about this at great length, so I'm going to slide over it for the moment. But Those three things are the things that I'm decorating that most efficient path picture with. Let's talk about it. My case in detail. First of all, software isn't plain geometry. So the fact that the first picture I showed you of the old school approach has such beautiful straight lines and seems to be so crystalline and perfect is irrelevant, because it's drawn on a plane, and forcing it onto that plane is actually what abstracts away all of the actual difficulty of doing that. Second point that I'll be making is that directed parallelization is extraordinarily hard in a particular way. Those of you who are computer scientists will recognize the expression NP hard or NP completeness. We'll talk about why directed parallelization is that and what it costs us, the fact that it is. The third point I've already touched upon, steps have intrinsic value. They have value just because they are steps, not for any other reason. And the fourth and final point, actually working for changeability costs less than trying to avoid change. That's partly because we have developed some pretty sophisticated techniques that allow us to do this. But it's also partly because there was actually no reason to avoid change in the first place. It's simply that we decided that the straightest line meant that we had to avoid change at all costs. Let's take a look at each of these in some more detail. The shortest distance between 2 points is a straight line. And look at that line. It's wildly not straight. I'm not gonna show you my brand. I'm a soda drinker, and I use them as comfort food, to be honest with you. I use them all through my day. I'm consuming sodas. And the nearest place at which I can buy some replacement sodas is Ashley's Market, which is about 1.5 miles that way. Think for yourself, just take a second, wherever you are right now. I hope you're all out on your decks having a wonderful afternoon, but wherever you are right now, what's the nearest place that you could go to get sodas? Suppose I was coming to visit and you said, oh my God, GeePaw's coming. We got to get some sodas in this place. Probably pretty close, just like mine, 1.5 miles, right? Now, draw a straight line between where you're at right now and that place. Would you say that the shortest distance is the straight line between those 2 points? Sure it is. Would you say that it would be a good idea to walk that straight line? In my case, the first thing that would happen is about 10 feet away from me, I would have to jump down 20 feet because I'm on the second floor of this house. Further, I would then walk down a long, steep ravine. Then near the bottom of that ravine, about a 45-degree grade, I would have to cross a river. It's not like, the Potomac, but it's, 40 feet wide. It's 6 feet deep. But then, soaked to the skin, I would then have to climb back up a softer grade, maybe 30-degree grade for about 150 yards. Then I would have to cross a wildly busy highway in order to get to my place. And the shortest distance it may be, but it is certainly not the most efficient distance. And that's the first point that I'm talking about on this slide. The surface itself has obstacles in it. The second point, unlike on that little plane and that sweet, perfect picture, we are actually traveling in a vehicle that changes as we travel. The vehicle self-modifies. What vehicle am I talking about? Well, I'm talking about our software, I'm talking about our project. Everything we do that makes a change changes the vehicle. So I'm working with a surface that has obstacles. I'm working with a vehicle that self-modifies. But wait, that's not all. Act before midnight tonight, and you also get the fact that unlike the terrain between me and Ashley's, the target and the obstacles move as you're trundling along in your self-modifying vehicle. Holy cow. Drawing a straight line and making it in geometric space or PowerPoint, frankly, making it beautiful in PowerPoint, requires extraordinarily detailed pathing. And there is no possibility of actually getting that level of detail with sufficient degree of accuracy. So the upshot of all this is me saying, not so fast. Plane geometry is perfectly good, provided only that you are on a plane. And we're not only not on a plane in the real world every day, all the time, we're not on a plane in software either. And unlike the real world, a mile and a half is such, a month and a half is actually such that the target and the obstacles will move during that time. The product that we're moving along will actually change itself. Next part of the case, directed parallelism doesn't scale. I mentioned NP hard. If it's been a while since you went through your computer science stuff, NP hard problems are problems that can be decomposed into multiple NP complete problems. What does that mean? Most problems in the real world, we can describe their difficulty at scale as we scale them up and down based on some input number, N, we usually call it, right? If the N is low, it costs you this much. If the N is high, it costs you that much, right? And we build this relationship between those two as a function. If that function is a polynomial, then essentially, I mean, it doesn't have to be linear like I've shown with this blue line, but it's pretty predictable and it doesn't swoop and it's stable. This is laying bricks. If it takes me 10 minutes to lay 10 bricks, it's going to take me 100 minutes to lay 100 bricks. Pretty straightforward stuff. Now, of course, some of those curves swoop down a little. It actually takes less effort because of economies of scale. That's what economy of scale means. Some of these lines we draw to illustrate that relationship aren't so simple. Non-polynomial, NP, means that a problem actually dramatically increases as you change that N. You know, almost all problems, the bigger the N, the bigger the effort. But NP problems, the bigger the N, the bigger the effort. So it's the difference between laying bricks, which is that nice blue line on the screen, and juggling bricks, which is that red line on the screen. Because here's the thing. If it takes you hardly any effort at all to juggle one brick, it's a good deal harder to juggle two. And I don't know how many jugglers I have in the room, but I'm sure most of you actually spend a fair amount of time just learning how to do 3, let alone 4. At 6, if you can juggle 6 items, you're actually good enough to go down to the mall and busk and get some spare change, because 6 items is actually extremely hard. And the most balls or bricks that have ever been juggled, according to the Guinness Book of World Records. Any guess in your mind? Go ahead, fix your mind on a guess. How many? What's the biggest number? 11. There are 2 people on the planet who claim to have juggled 11 balls around twice around the circle. That's all the test requires. One of them was caught on video. One of them is witnessed by reputable people. Guinness Book of World Records says it's a disputed title. We don't know, but it doesn't matter. The point is, the most you can do is 11. Nobody can solve the problem at 12. That's the kind of thing we're talking about when we talk about NP hard. Directed parallelism is, remember those 3 exquisite arrows with their straight track and everything? Well, how many people here, I can't even see your hands, I don't know why I'm asking this. Did you go to any meetings this week? Were they meetings about managing the parallel streams? Were they meetings about planning to make sure that your project proceeds in the right way? Did you have just the most wonderful and joyful experience while you were doing it? Furthermore, when you actually went to ship, when you actually went to deploy, was it exquisite? Or was it in fact 2 hours of high tension, then some running around like we're chickens with our heads cut off, then a couple of quick hot fixes, then cool, we're good to go. We can go live. Because that's what mostly is. And when you do that, what's interesting about it is every time something slightly different goes wrong, that is precisely because of the combinatorics involved in solving that problem, which is not just NP complete, it's NP hard. It contains within it multiple NP complete problems. And it is exactly the difference between laying bricks and juggling bricks. Managing your parallelism in this way is extraordinarily expensive, which would not be so bad if it worked. I mean, I can always build in extra cost into my project, right? The problem is it doesn't work. Directed parallelism does not scale because the curve is non-linear. My third point, this is a lousy slide, I'm sorry. It's late, but there's a lot of things going on here. I want to talk about that blue circle, the intrinsic benefit of steps. Oh, I don't know, you're probably at home right now. Most of you, I imagine, are. The dog could run in, or your child could, or your spouse could, or the phone could ring, or a colleague could be texting you and saying, hey, can you come take a look at this? Or a meeting could be called. All of those things could be going on. And if you are in the middle of a step, if you are in between two states of activation, there's nothing you can do about it except decide, oh, hell, am I going to lose all the work I've got so far and pick it up again later? Or am I going to go help somebody or take care of my kid or any of those things? But as the gap between activations shrinks, the stakes get significantly lower. Because, yeah, picking up my last 20 minutes of work, even for a team, picking up our last day and a half from scratch because we got interrupted, no big. It's a day and a half. It's nothing. It's chump change. If I'm a coder and I lose 15 minutes of work, whatever. 15 minutes is nothing. So, in fact, the intrinsic benefit, one of the first ones you get out of taking small steps, is interruptibility. But of course, interruptibility leads directly to steerability. I realize many of you are not in corporate settings, but are in government settings, but I think you probably have at least some of the same experience as we do in the corporate setting. Someone who weighs very much more than us will come in the room and say, I know I told you, forget everything but X, but if you could do Y in the next 3 weeks, I can close a $300 million deal. Steering. If all I'm going to lose is my last day and a half of story, of course I'm going to happily jump on that bandwagon and close that $300 million deal for you. But if that work in progress represents 6 weeks or 6 months, no way am I willing to throw away 6 months of worth of work, even to close a $300 million deal. And believe it or not, I even have an angry bureaucratic defense, which is that we documented what we were going to do during those 6 months, and you never mentioned this schmo with his lousy $300 million. You know this stuff happens. Politics are a part of work. So interruptibility implies steerability. Another aspect of this is it implies reversibility. If you take a small step and then you realize that the step is the wrong one, you know what you can do? You can take it back. You can take it back either directly by simply throwing it away, or you can take it back by moving your next step back to the way you meant the first step to go, right? This is reversibility, steerability, interruptibility. All three of them sort of work together. But I'm not done yet with intrinsic benefit. In the same way that we had a nonlinear curve for the managing the NP hardness of solving directed parallelism, we have the same or similar nonlinear curve for mental bandwidth. In 1954, George Miller, who was a psychiatrist, I think UC Berkeley, wrote a really famous paper, 7 ± 2, the magic number. It was subtitled, "I'm Being Persecuted by an Integer." And in his, it's based on a talk. And in his talk, he talks about, he's got all of these projects going with these graduate students, and they keep bringing him this data. What they were after was the idea of what makes up intelligence. But a number kept popping out of the data over and over again. And that number was 7 ± 2, the number between 5 or 9. And he proposed in that paper that what we were seeing was the limits of human mental bandwidth, that a human being can hold between 5 and 9 unrelated things in their head at one time. The experiments, and many, many more experiments, that was way back in 1954, have piled on thousands and thousands of data points onto that insight. And you know what the modern consensus is? He was wrong. He was totally wrong. Wrong. The actual number is 5 ± 1. Because what he was not doing was adjusting for the rather extraordinary capability of humans to relate things together completely arbitrarily. Both of those things are blue, even though blueness has no relevance to their fundamental ontological nature. Simply connecting them by something arbitrary like that actually helps humans a little bit. That's why he got the boost in his data. Grokability. What that means is my ability to make a change depends on how many entities are in play. The fewer the entities, the more likely I am to be able to understand the situation and make an effective action in that situation. That's what I mean by grokability. The longer the step, the bigger the step, the more entities are in the game. And the further we start climbing up that horrible Mount Nonlinear that I showed you in the previous slide. Grokability is an intrinsic benefit of smaller steps. Finally, rhythm. I learned this from doing test-driven development. I know I'm not really talking necessarily to a room full of developers. You might not know everything about that. That's fine. But when you're doing test-driven development, what you're doing is you're writing itty-bitty, teeny tiny tests, and you're passing them. You write them before you write the code that passes them. So we say red, green, red, green, red, green. And typically, I'm doing that every 10 minutes, 5 minutes, sometimes every 1 minute. And sometimes when I do it, I've got a red, and it's been red for about 10 minutes, and then I get it done. I get the green. And here's what I do. I go, and I run it again. And it's green, and I go, and I run it again. I know, I'm a rat pressing a food pellet lever. Boom, boom, boom. That's actually rhythm. Periods of tension alternating with periods of release. Tension, release creates rhythm. And rhythm feeds dopamine. I am sure at various places in your life, you have looked on teams and you said, these people don't seem motivated. I bet they weren't getting enough dopamine. When you take a big step, there's a big benefit at the end. We get this big reward, but the problem is the refractory time of that big reward is extremely short. In fact, it's not much longer than if it were a small reward. In fact, what humans need to optimize their performance is regular doses of tension and release. Smaller steps gives them those regular doses. Finally, the last benefit, target parallelism. We talked about parallelism as the 3 strands, right? But they all unified to a certain place. Part of the sort of fundamental 1980s model is the idea that we have one target, that we have one customer, that there is only one stakeholder, or if there's 35 agencies, all of those agencies agree on what the most important thing is. And you know that is not remotely true in life. In the corporations that I work with, frequently there are 3 people in the C-suite all demanding different targets from the same team at the same time. Target parallelism is a way to solve that approach. What it's saying is, instead of taking large steps that commit me for a long time to that gal's target and ignore that guy's target, I can take little tiny steps and advance both targets, and I can smoothly control the ratio of distribution between the various targets. So this allows me to satisfy stakeholders who have different voices and different views and opinions about the app. And I have to tell you, that's just one of those 6 benefits, but it is staggeringly huge. It's huge. Think about the last time you sat in a C-suite listening to these people argue about which way to move their project. The stakes are extraordinarily high. You get to the place where you get to see executive fisticuffs. These people are battling furiously. But if I could say, you know what, guys, I'm actually okay with both of those targets. I can help you achieve both of those targets. You don't have to decide one or the other. All you have to do is talk about what ratio of work do you want? Do you want 30% from column A and 70% from column B? Or do you want it inverted? Or do you want it 50-50? Or how do you want it? And it's because I'm taking small steps. Intrinsic benefit. You can tell this one really excites me. I've been sitting on the same slide for 20 minutes. Changeability and path-focused design. So this is the opening of 3 slides. I'm going to tear through them pretty quickly. But this is all part of my 4th bullet point, which is saying that, in fact, embracing change is actually far cheaper than trying to avoid change. We have learned an enormous amount over the last 20 years about path-focused design, which is, it's a design that is actually laying out the path in stride limited steps on purpose that they are stride limited. We've actually gotten pretty good at that. One of the things that's important to do here is, of course, reject the idea of finality and finish line and permanence. And the reason we're rejecting that idea is because it's just not there anymore in software. Software applications last for years and years. There's no finish line. Instead, we assume that things are going to change, and we assume that they're going to change in ways we cannot possibly anticipate at this time. And we let go of that beautiful, beautiful straight line diagram, which goes by the name of rework avoidance theory. We just let go of it. Now, interestingly, when you first introduce these ideas to your teams, you'll find that it's impossible. Nearly always, it's not impossible at all. In fact, it's relatively easy. The problem is they were never looking for it before. They were never looking for stride limited steps that were stride limited, non-negative, and activated. Instead, they were slipping in that big criteria. Must not involve changing anything I have already changed. If we can throw away that criteria, solving this problem is far, far easier. So there's other changeability techniques that have come from the Agile software movement. There's test-driven development. Not going to spend a lot of time here, but essentially what it amounts to is the most important aspect of it is automated consequence detection. The thing that makes me want to not change things is I don't know what's going to happen. Don't touch that. You don't know what it's connected to. But the test-driven development approach gives us automatic consequence detection. We can immediately know exactly what it was connected to. And because our step was small enough at the TDD level, you're talking a few minutes, you can revert it if it gives you a consequence you don't like. Automated consequence detection is extremely important because these systems are so big. There's so much implicit knowledge embedded in them that no human is capable of holding all the potential consequences in their head. There's more changeability technique even behind that. Working by story, pairing and mobbing, trunk-based, and the methodology that, methodology is a bad word, the method we call pull and swarm, where we pull one story at a time, we get everybody on our team working on that story, and we ship that story, then we pull another one. That's pull and swarm. All of these are attempts to optimize. Working by story is optimizing our focus. Pairing and mobbing is optimizing our collaboration, our ability to talk to one another and to have shared language and shared ideas about our shared project. And trunk-based and pull and swarm work optimizes parallelism at the minimum cost. It's not free, but at the minimum cost that we can use to achieve parallelism. There's no free lunch. We have to unlearn pre-commitment. We have to loosen our pride clamped on hierarchical command and control fingers off of that. And we have to stop doing overly simplified additive production reasoning. The A plus B plus C plus, oh, I'm going to multiply all these. That's laying bricks, but we're not laying bricks. We're juggling them. And addition is not adequate to account for our productivity. Meanwhile, we're going to have to learn things like test-driven development, like path-focused design, like mobbing and pairing and swarming, and all the various forms of collaboration that this kind of arrangement involves. So I'm not going to tell you it's free because it's not, but it's cheap, and it's a lot cheaper than getting to the end of that 3-streamer and not having anything to show for it. First, throw everything at a walking skeleton. Second, adopt those 3 criteria. It must be stride limited. It must be activated. It must not do any harm to the customer. Third, use multiple teams adding steps to approach, this is the walking skeleton stuff, from walking skeleton to minimum viable product. And then fourth, keep going. Keep going after that using exactly the same technique. Effective change, the most effective route to change, throw up a walking skeleton and start using stride limited activated steps. And you'll get there faster and you'll get there happier. That is my absolute strongest possible advice. Now you notice that I said effective change here. I didn't say effective product. I didn't say effective program management. I didn't say portfolio. I didn't say process. I didn't say code. Because in fact, this idea isn't about any one of those. It's about the nature of effective change. Now, I learned it by doing TDD, but I'm not saying you should go learn TDD in order to learn this. I'm saying once I became a coach, I had to start thinking about effective change in organizations, effective change in processes, effective changes in how we do our work and what kind of communities we want to create. And I learned from TDD that actually this scheme I'm showing you right here works pretty well, no matter what it is that we want to change. Our code, ourselves, our process, our team, our organization, our trade, or, and here's my pitch for social activity, our world. If you want to change the world, and I certainly want to change the world, we need to look outside our projects, and we need to move around in the world, and we need to change things using exactly the same thing. Take many more, much smaller steps. It's blind advice. I don't know you folks. I don't know your context in any detail at all. I can still give it to you freely and safely because 9 times out of 10, even if I did know your context, I'd be giving you exactly the same advice. I'm done. Thank you very much for hanging in there. You can always follow me on Twitter. It's GeePaw Hill, GeePawHill. I will not only talk about this stuff, I'll also talk about my fascination with 20th century American popular music and, yes, politics. So pop in anytime, say hi, let me know if you came from this meeting. That would be great. Thanks very much. Back to you.